Talk about all types of nomenclature today and review it. You're going to be taking a quiz this week on all the different types. And so the first thing we're going to do is really look at how do I differentiate between them. So the first thing you have to look at, the number one thing you do on every problem is you make sure you look at the element that is on the left side. Okay? So when you look at the element on the left side, the first thing, is it an H? If it is a hydrogen, then you know that you have an acid. Okay? And so you're going to follow the flow chart. You're going to follow the acid nomenclature rules that we've gone over. There's two types of acids. There's binary acids, which is hydrogen and a non-metal. You're going to always have a hydro prefix on a binary acid. You will always end in ic acid every time. So a great example of that would be H2S, and that is hydrosulfuric acid. Notice, it has a hydro prefix and it ends in ic acid. Okay? The other thing is this. You know the number of hydrogens you have by the charge. It has to cancel out the charge of the non-metal. So if my non-metal is a -2, I'm going to have 2 hydrogens. If my non-metal is Cl and a -1, I only need 1 hydrogen. So this would be hydrochloric acid. All right? The other types of acids would be if you had hydrogen in a polyatomic ion. And the thing about that is you never have a hydro prefix on these. These are called ternary acids. Ternary because of the polyatomic ion. So you never use the prefix hydro. So we just take that out. Right? So it's just the polyatomic's name. And then if the polyatomic ends in ATE, you're going to change it to ic acid. If the polyatomic, like H2SO4, this is sulfate. Okay, so it's just sulfuric acid. The ATE becomes IC acid. If your polyatomic ends in ITE, then it's going to become OUS acid, like sulfite. Notice there's no hydro prefix, it's just sulfurous acid. All right? So if I had nitrite, which is NO2, notice that's a -1 charge, so I would only need 1 hydrogen now. The reason there's 2 hydrogens here is because these were -2s. So if I have nitrite, then that's going to become nitrous acid. All right, so there's no hydro prefixes, just the name of the polyatomic, and then if it's an ATE, it goes to IC, if it's an ITE, it goes to OUS. All right, so that's if it starts with hydrogen. If it starts with a non-metal, so if the element on the left is a non-metal, which how do we know if it's non-metal? It's to the right of the staircase. All right, so that means it's a covalent molecule. Whenever you have 2 nonmetals together, you always use prefixes. That's the big key with covalent molecules, is you always use the prefixes. All right, and that's because of the law of multiple proportions. They can exist different ways. All right, so your formula that you're going to follow is prefix, full name of the element, prefix, name of the element, change to IDE. So if I have N2F5, that is going to become dinitrogen pentafluoride. All right, so it's di for 2, so 2 nitrogens, dinitrogen, pentafluoride is 5 fluorines. Now, there's 2 little rules that you have to follow when you're dealing with molecules. The first one is you do not use the mono prefix on the first element. So no mono on the first one. So if it's CNO, that's just carbon monoxide. It's not monocarbon monoxide, it's carbon monoxide. The second rule is if it's an oxide or an iodide, you drop the A or O on the prefix. All right, so we did that in this one too. So carbon, instead of monoxide, it's just monoxide. All right, and then this one right here. If there's 2 sulfurs and 5 iodines, it's disulfur, and instead of being penta-iodide, it's pent-iodide. So we drop the A there. All right, so for covalent molecules, you have to use prefixes, and those are the only ones you use prefixes for. So going back to our thing, we're looking on the left. If it is a metal on the left, then that tells you we're going over to this side, and that is ionic. Okay, that is an ionic compound made up of a metal and a non-metal. There's 2 types of ionics. There's binary ionics with 2 elements, so there's only 2 capital letters, or there's ternary ionics made up of a metal and a polyatomic ion. If it's binary ionic, the metal keeps its name. You never use prefixes. The most common mistake people make is they want to start putting prefixes on everything. You do not do that. The only things that take prefixes are the covalent molecules. So you never use prefixes on binaries. And the nonmetal always changes to IDE. So an example here would be MgS. The first element's magnesium. The nonmetals change to IDE, so it's sulfide. Okay, now the one thing you have to look out for with binary ionic is the transition metals. If there's a transition metals, it can have multiple charges. So because of that, you have to show the charge with the Roman numeral. Okay, so show the charge with the Roman numeral. So if I have CuS, all right, that's copper and sulfur together. So I know it's going to be copper sulfide, but copper's in the transition family. Remember, the first family is always +1, so no Roman numeral. The second metal family is always +2, so no Roman numeral. But for the transition metals, these are the guys that are going to get the Roman numerals. All right? And then underneath the staircase also. All of those get Roman numerals. All right? So, copper's involved in that. Now, I don't know what the charge is. I know it's a 1-to-1, and I know that sulfur is a -2, so that means this has to be a +2. So it's copper 2 sulfide. And the biggest mistake people make with this is they want to put the Roman numeral to represent the subscript. And the Roman numeral never represents a subscript. The Roman numeral represents the charge, which is the superscript. Okay, so if you have something like this, people always want to put iron 3 nitride, and that is not correct. This is iron 1 nitride. And that's because nitrogen has a -3, iron has a +1, so it's 3 and 1. All right? And which takes me to my next point. Whenever you're doing ionic compounds, you have to crisscross the charges because there's only one way to write them. So if you're going from the name to the formula, you're going to write out the names, and then you have to put the oxidation numbers over them and crisscross them. So if I have like lithium and sulfur, lithium's a +1, sulfur's a -2, so I crisscross the oxidation numbers and reduce, so that's going to be written just Li2X, because if it's no number, then it's an understood 1, and that's lithium sulfide. Right? And the last one, and it follows the same as the binary ionics, is the ternary ionics, and that's when you have a metal and a polyatomic ion. Now the good thing about these are the easiest to name because the metal keeps its name and the polyatomic keeps its name. You do not change these to IDEs and you do not use prefixes. So CO2SO4 is going to be cobalt 2 sulfate. This is Mg3PO4 parentheses 2, that's magnesium phosphate. And the reason why the 3 and the 2 are here is because this is a -3 charge, this is a +2, so you crisscross the oxidation numbers. But remember, always put the polyatomics in parentheses, okay? And then over here, this is a Roman numeral metal again. So if we don't know what this is, but we know that this is a -2, and I have 5 of them, that gives me 5 times -2, my total negative charge is -10, so it's 2 times what equals +10, because remember, the total charge of a compound has to cancel out. The positive and negative side have to cancel out. So what times 2 equals +10? That's going to be +5. So that's why it's cobalt 5 sulfate. All right, so hopefully this helps you with your nomenclature journey, and we have a quiz on Wednesday. Have fun.